Hi, I'm Bob McDonald. I'm the host of Quirks and Quarks, a science show on CBC Radio. I'm a correspondent for The National on TV. I'm also an author, and if you don't mind some self-promotion here, this is my latest book, An Earthling's Guide to Outer Space. Great for kids. I'm pleased to be here to host this conversation on behalf of Engineers and Geoscientists BC. For those of you who may not know, this is an organization that's the regulatory and licensing body for the engineering and geoscience professions in BC. To protect the public, they maintain robust standards for entry into the professions and comprehensive regulatory tools to support engineers and geoscientists in meeting professional and ethical obligations. If those standards are not met, they take action through their investigation and discipline processes. BC's engineers and geoscientists are explorers and problem solvers who lead the way in public safety, quality, and innovation. I'm here today to have a conversation with two recipients of the 2020 Engineers and Geoscientists BC President's Awards. Dr. Loretta Li is a professional engineer and the winner of the R.A. McLaughlin Memorial Award for her research on contaminants, such as metals and other vehicle byproducts that have been dispersed along highways. Her research has led to collaborations with the BC Ministry of Transportation and has led to over $40 million that was saved in soil management costs. Next is Dr. Dan Moore. He's a professional geoscientist and the winner of the C.J. Westerman Memorial Award for his work in hydrology, specifically for refining a method of collecting and analyzing stream discharge data in a much more safe and accurate way. Now, I'll be speaking with both our guests about their careers, also about their inspiration and how engineers and geoscientists are keeping people safe here in BC. It's going to be a fun conversation. But just as a final note, if you are watching this right now but prefer listening while you're on the go, there's also an audio version of this conversation that's available through Spotify, iTunes, or your favorite podcast player app. If you are listening but prefer to watch, you can find the video on our Engineers and Geoscientists BC YouTube channel. So, without further ado, Loretta and Dan, welcome, and thank you both for being here today.
Thanks, Bob, for having me.
Thank you.
So I want to ask both of you, if you can just in a few sentences tell us about your research that's garnered this President's Award. And Loretta, let's start with you.
It is my research in environmental pollution, emerging contaminants, freight and transport, risk and remediation. Now,
I was saying that you see metals on the sides of the roads. I didn't know metals came from cars. What do you find?
Depending on the age of the highway, if the highway is an older highway, commonly you will find lead. If it's a newer highway, because of the replacement of the lead in the gasoline, so some of the contaminants could be depending on when it was built, it could be manganese, and there are other contaminants, for example, pH or petroleum hydrocarbon.
Oh, okay. So they're contaminants coming out of the tailpipe, not metal coming off the car itself.
Well, when it's operating, the cars are running, and there could be due to the combustion. It could be the wearing and tearing of the tires, the car body, corrosion, etc., the road wearing.
Wow. Dan, tell me about your research.
Well, my research broadly falls into a broad rubric of environmental change, catchment hydrology, and the stream environment. So I study processes such as forest disturbance and forest management, and glacier response to climate variability, and how that influences the flows in rivers and the habitat for fish.
So you found a better way to sample the rivers?
Yes, and so some of my work has focused on better ways of monitoring rivers, and this one approach that we've used is to refine a technique called dilution gauging that's been used for decades, but I was dissatisfied with some aspects of it, and so I did a lot of applied research with some graduate students to refine the method so it's more reliable and more accurate.
Does it also mean you don't have to get wet? You don't have to get in the river?
That's right. That's a big advantage, especially when the rivers are getting high. They can be a real safety issue.
Loretta, can you tell me a bit about your career path? What led you to the role of engineering that you're in today?
In engineering, almost everything is related to engineering. When I first picked up engineering, it was, going to the university, but basically by elimination, but it was a good choice.
In the past, engineering has been largely dominated by men. There weren't many women in it. What's it been like for you in that regard?
Right. I was the only female in the class. And even when I was in graduate level, all courses that I had been taken, I was the only female. So in the beginning, it was a little bit hard to adjust from a all girls school and all girls family to adjust the all male environment. But I got used to it.
What else do you think could be done to improve equity and diversity in engineering?
I think all rules and bylaws should be carefully examined to ensure gender neutrality. And also salary scales must be examined to assure equal pay for equal work. And also women should be recognized in the same way for their contribution.
Dan, how can geosciences advance equity, diversity, and inclusion?
Well, I think that having role models in the academy is really important. I had a research assistant who told me that the reason that she came to our department was that we had a female geoscientist on our faculty who was doing exciting work. And so you really need that. I think another important thing, though, is for people like me who are getting towards the end of our careers to make room for younger people, and especially to allow for more diversity. For example, on committees, I don't need to be on all the committees. I don't need to be a speaker at a conference. I can give a poster and make room for other people, especially the early career researchers.
Mm-hmm. I guess it's always that case of you want to see someone who looks like you in a profession before you go into it.
Exactly.
Dan, was there a moment for you, an aha moment that kind of awakened you to science and got you interested in it?
When I was very young, I remember really being captivated by the Mercury and Gemini launches of the space program, and really being impressed and motivated by that. And an early visit when I was young to the Seattle Science Center as well. And I just have really loved science ever since then.
I was also inspired by the space program, and I had a wonderful opportunity not too long ago. I was at a conference about going back to the moon, and the guest of honor was Buzz Aldrin from Apollo 11, right, the very first moon landing. And I was sitting right beside him, and there's Buzz Aldrin. So I threw out a question just as a chance. I said, "Hey, Buzz, would you like to go sailing tomorrow? I have a sailboat." And he looked at me and said, "Sure." So I took Buzz Aldrin sailing. I couldn't believe it. So it was a very inspiring time. Who is someone in your life that's been a role model to you? A mentor, family member, anyone? Who's been a role model for you?
I would say my university mentor, Dr. John Grace, who is a previous recipient of the President's Award. And he always encouraged me, including this podcast.
Wow. Dan?
I would say that two of my professors, when I was an undergraduate, Gary Clark, who's a geophysicist who studies glaciers, and Michael Church, who's a geomorphologist who studies river dynamics, they really had a huge impact on the way I approached being a geoscientist.
Do either of you have famous scientists that you look up to or that are heroes of yours?
Stephen Hawking.
Stephen Hawking. Dan?
Amazing.
It certainly was.
Oh, to be honest, I'm really drawing blanks, but I would have to say somebody like Albert Einstein, who wasn't afraid to think outside the box.
What parts of your job do you find the most challenging?
Well, right now it's teaching remotely. I find it really difficult to engage with students when it's mediated through technologies like Zoom. You know, it's better than nothing, but this really is the most challenging thing I've experienced in my 35-year career.
I think we're all challenged by Zoom meetings and Zoom conversations. What do you find the most rewarding?
Throughout my career, the most rewarding thing definitely has been working with my graduate students. I just love seeing these bright young people becoming really geared up and really excited about science, and because they often can learn new techniques that I'm just kind of getting too old to learn, and so I vicariously learn stuff through them. It's great.
Loretta, what parts of your job in trying to measure contaminants along roadways do you find most challenging?
In my job, I find the most challenging is teaching large undergraduate classes and holding students' attention. And with respect to research, the most challenging is writing research proposals. It's just hard, must be persuasive, and must be able to encourage the reviewers to buy my idea in order to get the funding.
Where did you get your inspiration? What drives you to do what you do?
Well, my wish to succeed. I love what I am doing, both teaching and research, and I want to be part of the solution.
That's great. It must be very rewarding then when you are. Dan, where do you get your inspiration?
Oh, a large part of it is just being really curious. Always being outdoors and looking at things and thinking, why is that the way it is? Or why is the water going in that direction? Why are those plants over there? So curiosity is a big driver. And there's just a real joy in when you can put the patterns together and answer those questions that you set. And like Loretta, I also find that having people find my work useful, being able to contribute through that work as well is very satisfying.
Mm-hmm. I must say I share your enjoyment of curiosity as a journalist, because I get to ask scientists, what are you doing? And they're just exploring the universe. It's all about questions. It's, why is the universe so big? Where did it come from? How does it work? Why is the sky blue, the grass green, and all that? And it's amazing how science is such a good tool to just answer those fundamental questions, and engineering is part of that.
Yes, and I find we can always find more and more interesting things.
Yeah, questions lead to more questions, right?
Exactly. What I find is more I know, more I find I don't know.
Now, I know that part of the scientific process is also failure. Not all experiments are successful, but sometimes they set you up for success later on. Loretta, have you had that happen?
Well, Bob, what I find is life is full of challenges. I don't think much about failure. If I don't succeed, I work hard to achieve the mission to success. Just go on trying and evaluate why I fail and try again.
Dan, have you had a failure? Have you fallen into a river or something? Learned a lesson from something going wrong?
Oh, yes. Well, falling into a river, didn't quite fall into a river, but I had an instrument that wasn't quite tethered on properly. I was lowering it into a river from a bridge, and I had to go for a swim to retrieve this very expensive piece of equipment that had gone into a cold river not too far from the Arctic. The other one that's more embarrassing is I lost almost a full field season worth of data because I plugged an instrument into the data logger incorrectly. What I learned from that was always double check, triple check, and take a photo if you can of the instrument so you can check it and make sure that everything's plugged in right.
Yes, indeed. I know during one of the moon missions, when they were walking on the moon and there was a very sensitive instrument that was set up on the ground, I think it was a seismometer, and one of the astronauts tripped on a cable and pulled it out and couldn't get it back in, and the whole experiment was lost just because they didn't notice the cable and tripped over it. So it's frustrating when little things like that can get to you and destroy everything. Loretta, how have you seen the profession of engineers change since you started?
When I was a student, I have to write my own programs. Right now, there are existing programs that's available. They only need to plug in some of the parameters. So I can see there is a huge change.
Change for the better?
If I stay positively thinking, I think it could be for the better. But there are always a flip side of it.
What would that be?
I would say when I was a student, we learned a lot of fundamentals, including the programming and all those. But now if you think about 1 + 1, then you just take a calculator, 1 + 1. Same as if you already have a program available, you just need to plug in the number. Maybe some people do not agree with me, but that's what I feel. When I start everything very fundamental, I learn the basics. And I can think about the origin of the problem, what is missing. A lot of things, there are assumptions being involved. If you only use the final product, you just miss that component.
There's a saying for that. It's called information rich, knowledge poor. Because information we can get on our devices really quickly, but is it sinking in this way? That's a really important point. Dan, how has geoscience changed since you started?
Well, there's been a tremendous growth of technology, the increasing use of computers, platforms from space where we can get gigabytes, petabytes of data. Data used to be so hard won. You go out in the field and you'd measure things, and now you can. The new missions are just incredible. Measuring water levels from space, it's just incredible the types of data that are now available. But on a non-technical side, I think one thing that's interesting is that there's been an increasing shift to focusing a lot more on the human dimensions of problems rather than just purely technical aspects of the problems. And I think this is so there's been a lot in geoscience, there's a lot more kind of reaching across and engaging with social scientists, for example, and engaging with policymakers. So I think, yeah, the discipline's been shifting from really a purely technical discipline to kind of a much more holistic discipline.
Well, I guess we're realizing our impact on the environment and the other way around, the environment's impact on us and how we have to get along with it.
Exactly.
How has climate change impacted your work?
I think there's a couple of dimensions to it. One is that it's increased the interest in the work that I'm doing. I've been interested in the effects of glaciers on downstream rivers for 30 or more years. And given that the glaciers are shrinking, and we've actually been able to document that we're getting reduced summer flows now in rivers in British Columbia and many other parts of the world, this work is becoming very of great interest. I've been working with BC hydrologists on this topic. And in another dimension, it's created interesting opportunities. I've been studying a glacier north of Whistler for about 15 years, and in that time it's retreated 4 kilometers. And so we've been able to see in a very rapid time how the watershed functions differently as the glacier retreats and as vegetation starts to grow in behind the glacier, or where the glacier retreated. So it's very interesting.
Mm-hmm. I feel that every time I go to the Columbia ice fields on the Icefield Parkway. First time I went there was 1973. And there are markers there for time. If I stand where I stood in 1973, it's like you say, a kilometer away now. It's scary. There's a saying that we fought wars over oil in the 20th century. We're going to be fighting wars over water in the 21st century. Do you believe that?
I believe that there will definitely be an increase in international tensions. I hope we don't have wars, but yeah. But there's definitely going to be a lot more competition for water resources.
And Canada is the water keeper of the world. We have more than anybody.
We do, but that's at a very aggregated level. If you look at specific times and places, there's actually shortages of water.
Loretta, how has climate change affected your work?
Climate change has great impact in the stormwater. The worst situation is the first flush. That means when first the rain start, that would contain much higher contaminants. And it's amazing nowadays you can find in terms of stormwater what could be the contaminants. It could be a lot of emerging contaminant and with PBDE, perfluorinated compound, and as well as 6 PBD that's found in the tires after degradation. So some of those are potentially carcinogenic.
How do you consider public safety in your work?
Public safety is extremely important related to my work as in environmental engineering. And the project that I work with related to risk assessment, remediation, that's related to public health. And the courses that I teach also has a lot of this information incorporated in my environmental courses related to health, safety, and the environment.
Dan, how's public safety incorporated into geosciences?
Well, there's many aspects. For example, dam safety involves geotechnical work. My own research, I think my contributions or where I try and fit into that is by helping to make sure that we have the best possible data and the best possible analytical tools so that we understand what we're working with. I also have done a lot of applied research that's really more focused on not public safety per se, but protecting environmental values like fish habitat. For example, management of riparian forests to minimize the impacts of forest harvesting on stream ecosystems.
What is one piece of advice you would give your past self? If you could travel in time and talk to your past self, what advice would you give?
Well, I would say work hard, but leave enough time, make contact with professionals and artistic interest.
Oh, so keep an interest beyond engineering.
Yes, there are so many interesting things.
Have a life.
Correct.
Dan, what would you say to yourself if you could go back in time when you were just starting out in your career?
Well, I don't think there's that much because when I look back on my career, I can't really think of anything I would have done fundamentally differently. But I would probably say pick up playing the guitar. Yes, something I've been doing in the last few years, but I wish I'd done it earlier.
Good. I'm with you on that one. Where do you see the potential in British Columbia here? I guess what's getting you excited over the next 10 or 20 years in engineering?
Well, I see the potential in particular British Columbia for application of advanced training in all engineering and geoscientist disciplines. In particular, we are close to the close line. Climate change is an important component. We are next to the ocean, and also we can advance further in the renewable energy, environmental protection, reduce microplastics. So there are a lot of interesting things that I think it would be of great interest.
It's sort of time for the engineers to shine because we're looking for alternative ways to produce energy and, get along with the world. And a lot of that technology is already there. We just got to implement it in some way. Dan, where do you see geoscience going in the next 10 or 20 years?
Well, in my own specific area, I think that we need to know a lot more about how climate change and various land uses are going to affect fish habitat. That's one area that personally I'm very passionate about. But also, as Loretta mentioned, green energy. I think, and you mentioned that, I think that green energy is something that we really need to work more on. And because a lot of green energy comes from, hydro, wind power, that's all falls into the bailiwick of geoscience.
Well, that's all the time that we have right now. This has been a really interesting conversation. I want to thank Dan and Loretta for joining me, and also to our listeners for joining us today. Hope you learned something or found it inspiring, interesting from what you heard. Dan or Loretta, do you have anything to add at the end here? Loretta?
What I would like to say is, Bob, thank you so much for these interesting conversations. I really enjoy it.
Thank you so much, Loretta. Dan, do you have any final words?
No, just thank you, Bob.
Well, it's been my pleasure talking to both of you. Thank you. And if any of you listening to this know an exceptional engineer or geoscientist, I encourage you to nominate them for a President's Award. Nominations are now open, and the submission deadline is Friday, April 9th, 2021. For more information about the awards, you can visit the Engineers and Geoscientists BC website at egbc.ca. Thank you for listening. I'm Bob McDonald.